Assalamualaikum warahmatullahi taala wabarakatuh. First of all, I want to introduce myself. My name is Muhammad Rafi bin Abdul Rahman. So today we are from Group 4 and present about hydraulic practice 1 PDJ 19101 Engineering Technology Practice 2 Lecturer Dr. Adam bin Kasani. Assalamualaikum warahmatullahi taala wabarakatuh. So today I will explain about introduction of hydraulic of practice 1. Okay, hydraulic systems operate based on Pascal's law. Pressure applied to fluid is transmitted equally in all directions, widely used in industrial automations, heavy machinery, and load handling systems. This experiment used a hydraulic trainer with a double acting cylinder. Okay, next I will explain the objective. Okay, the first one is to design and operate a basic hydraulic control circuit. The second one, to analyze pressure behavior at inlet port, outlet A and outlet B. Then the third one is to compare pressure values during cylinder extensions and cylinder retractions. Okay, we're going move to the hydraulic. Okay, the first one, the component is hydraulic pump to supplies pressure oil. The second one is 4/2 directional control valve, which is have four ports P, T, A, B, and have two position extension and retraction. Okay, the third one is double acting cylinder is to performs linear motion, and the fourth one pressure relief valve to set a 40 bar to protect system, and the last one is pressure gauge is to measure inlet and outlet pressure.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yaur Rahman bin Alias with the matches number of AD240007, and I will explain about the experimental procedures. So first, system pressure adjusted at four types of quantity: 10 bar, 15 bar, and 20 bar, and lastly 25 bar. Second, cylinder speed fixed at 20 cm per minute, and third, for each pressure, we will record inlet pressure and outlet A and outlet B. And lastly, measurements will be taken for extension stroke and retraction stroke. Next, results cylinder extension. Let's look at the actual data for extension. This table breaks down pressures at different points: the inlet port, outlet A, and outlet B. At 10 bar system pressure, inlet is 9.6 bar, slightly lower due to valve losses. Outlet A, which is the piston side during extension, reached 8.4 bar. This is the driving pressure. Outlet B, the rod side return line shows only 1.2 bar. This is the back pressure. As system pressure increases, all values rise proportionally, which tells us the system is behaving predictably. And next is cylinder retraction. The retraction data table. Now the roles of outlets A and B are reversed. During retraction, the inlet pressure is still close to system pressure, but now outlet A is low around 1.3 to 3 bar because it's the return line. Meanwhile, outlet B becomes the driving side. The pressures from 8.1 up to 22.3 bar. This swap is due to the directional valve shifting flow, which is exactly a double acting cylinder should work. Next is graph hydraulic gauge pressure result extension. Here we have the gauge pressure results during cylinder extension. This graph shows how the pressure in the cylinder changes as we increase the system pressure from 10 to 25 bar. As expected, during extension, pressure builds on the piston side to push the rod out. We can see a clear upward trend. The higher the system pressure, the higher the gauge pressure during extension. Now, moving to the second slide, the retraction phase. During retraction, the cylinder pulls the rod back. Notice that for the same system pressures, the gauge pressure is generally lower compared to extension. That's because the piston area on the rod side is smaller, so less pressure is needed to retract. Still, the trend is consistent. As system pressure rises, retraction pressure also increases.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syarif Rifki bin Syafruddin. My number metric is AD240079. Now I will continue the presentation for observation part. So from 8, 10 to 15 bars, we can see that the cylinder movement become only more slower and slight hesitation at start. After that, at 20 until 35 bars, the cylinder become more faster and we can see the motion become more smoother. So it because that small pressure fluctuation observed due to pump pulsation and manual lever operation. After that, we can see that no leakage observed. Now we move to discussion part. First, the pressure behavior followed hydraulic theory. Second, the linear relationship between system pressure and inlet pressure. Third, retraction requires high pressure because the roadside area is smaller. Fourth, the pressure relief valve did not activate since the working pressure is less than 40 bar. Last but not least, system operated safely and correctly. So the conclusion for our practice is hydraulic circuit successfully constructed and tested. Also, we achieve our objective of experiment, and the pressure reading clearly showed the effect of pressure drop and effect of piston area difference. Last but not least, experiment enhanced understand of DCV operation, cylinder motion, and hydraulic safety system. That's all from our team. Thank you.